The model is completed, and the all of the item and the all of the step of this tunnel, all of this model completed, and we have exe right tunnel 0.202 f3 save. It means the second tunnel in right hand, right this side is completed also. So now we should check the output related to the displacement, settlement, and plastic index or plastic zone around this tunnel, and also the strain, velocity, and also stresses. And also we should check the support system, because as I said, we need to check the stresses or bending or shear or axial load, axial force in support system, because we want to find the best and suitable the number of IP and S3 arc steel set, and also thickness of shot crate, because we want to have an optimization. So let me show you. Also, we have this is a support system. We have a shot crate and a steel set. As I explained for you, the distance between this the arc or steel sets are 1 meter. So now we can check the displacement from here by, let me show you just the left tunnel. So also let me off this beam group by pressing Shift X on the keyboard and then move it to the view. We can see the displacement in top of this tunnel, and also we can check. You can see the displacement is 1 centimeter, just only larger than 1 centimeter. And it's maybe unusual, but we need to check all of the output, or output needed to check the stability. From here, let me change it to labor, and this one to state. We can see the some zones around the tunnel in bottom and top, and in the wall have some failure. It's maybe in the portal is too large. It's a local failure. It's maybe, and also it's back to the stability. Not need to check here, because we don't need to check the slope tunnel in this example. So we can see there also in this side of tunnel also there is some instability and failure plastic zone. The more of the instability or failure are in tension P. It means tension past. Also red color, it's for shear P. Okay, for another side of tunnel, I can also see this here. It's a smaller in smaller value because the overburden is smaller related to this tunnel. And also let me press Ctrl R on the keyboard. So from here also we can, let me check the strain. Let me change to contour, and from here we should to check the strain ratio, strain increment. Sorry. From here, let me back it this one to this value. There is some value larger than 1 centimeter or 1 millimeter also. It may be the value larger than 1 millimeter. It's maybe have a failure in this ground condition or in this ground type. It's usual. If we back to the state, we can see the some instability in the tunnel in this color also. Okay, so related to the also for support system, let me show you the. You can see the beam area from here, 2ID beam. As I said, we can check the differ ID, number IP for two tunnel. For example, this one is 18 and this one is 16. We can use, but in this example, the all of the IP or still set are 18, number 18. So we can check the displacement. We can check the stresses displacement in the rack arc still set. Let me off this one. So also shell, we can see the value of displacement in this one. It's too large or too much for this steel set. Also from here we can see, we can check the also yield state link, or it's maybe when we have a link for this one. Sorry, for this one we should to check shear force, and also we can check the moment in the in this support system. Also, we can check bending moment, and also we can check the axial force, axial stress. Axial stress, it's maybe have a good. You should to check to output, and also axial force, axial stresses, and also another output. Also for check the structure diagram capacity for this support system. As I said in the first of this example of in the first of this chapter session, we should to check this output by an analytical method or another calculation. As I said, uh, there is a reference to check by this reference is for Earth Hawk for this years. Uh, so for it, there is a calculation. Let me move to. Okay, we say about this output. This output, we should to check the lattice grade or shot grade. If it maybe have uh, a steel set, it is also for a steel set. Let me found it. Okay, a steel reinforcement and concrete lining, and this one and this one. We should to check and also all of the calculation or equation are there for this methods in the chapter. It may be as I remember, it's in the appendix 2. Let me move to right. When we have this condition in NST MST, it's made for it's a steel set, and S in shot grade, M shot grade, and also Q. So all of the calculation are there from here. The all of calculation there are. So you can see the appendix 2 from this reference for this calculation. But also it's related to the FS. It's a factor of safety for substructure diagram capacity. So also shear force, normal force, or also bending moment in this support, and also support capacity plots. How we can plot it? Don't worry about it. There are also Excel to calculation for it. You can use this Excel for it. We prepare it to you. So and also we send to you this calculation method and this output. There is a calculation for this one, and plot capacity plot for you. And also we can use the FLAC 3D. Let me show you from here. There is a FLAC 3D calculation for you. I write this one by fish function when you want to select the still set IP number 16, also for example 1614, sorry, 1614, 16, and also 16, 20, 18, anyone like this one. So in this method, in this example, as I said, the IP is 18, and the calculation for it also there is, you can change or use. For example, from here there is a FS, factor of safety for support system. You can change it to your desired factor of safety related to the stress condition and also support system condition ground condition in your model on your project. Also there is a check for all of the uh, all of the support structure, and it's just we need to run, not needed to any writing. I sent for you this one also. There is a how we can check the support system by the beam by beam ID or by structure type beam. There is a axial BF, shear BF, and bending moment MB. And also we should to input this value in the table to plot it, all of the structure type by the beam type that have a beam, and also forces in XZ and also for Y. Okay, uh, let me run this one. Let me execute this one to check. There is a plot also for it. You can check, you can see the plot. There is a maximum value relative to this reference. To plot it, there is a maximum value for Q and M and M for this one. You can see MN for the first for the calculation for the first plot, and also there is a for shear force axial thrust from here, Q, N, and N, maximum, minimum for it. So let me move to software also. Also there is this one. You can see that just some number near to the boundary. Let me back to also, you can let me check it to FS2 1.5 from here. Okay, sorry, let me found it. From here, let me check it or change to 1.5, and again run it. You can see the number of the element of the support system structure element. It's maybe have failure or near the boundary of this limit for this structure, the diagram capacity limit. So for this one also there is some value, some element. It's maybe having a slope. It's maybe having the middle of the highest of the overburden. We can also check it, or we can plot it or list it by a structure beam list for bending moment, for also axial for shear for, or any output. Also the maximum of this, the most of this element or structure support system are in the have a good suitable in axial force or bending moment or any like this. So so uh, my advice is we can have some differ or some addition support system to change between the advance in steel set, or also in number of a steel set in some condition that have this this failure. So for another one, we can check it like this. There is a another question is maybe have a how we can plot it. There is a table for you. Let me have another table for you or another plot. So from here we can uh, add a table chart, and then we can add this one, this one, this one, and it's maybe all of the boundary for structure diagram capacity for Qn, and also plot related to this one is a SQN. So now we should to check or change the some setting for you for the suitable output. So from here we should to change this one, the series to from here to point to mark. You can see change it to position or point. You can change also from here to diamond or also star or also seeker or any like this, pound also. Let me back to plus the size of this plus for plus point, and also we can change the color from here to, for example, this like this color, or this one also to have a this color, and also this one have a this color, and also this one have a green color. So now we have a output for it. So we can plot it or export by a bitmap to check or add it to our document. So for another one, also there is a master file for check the all of or plot the all of the output. We can just by execute this one to have all of the output. Let me move to this folder. There is all of the output. Let me move between in this output displacement is section in 1 tunnel and 2 tunnel for investigation. So all of this output, okay, in any desert changing or location.